Hello, everyone. This is another episode of the podcast by the IEEE student branch at Nazarbayev University. And our today's guest is Professor Prashant Jamwal, PhD, professor at the School of Engineering and Digital Sciences, Department of Electrical and Computer Engineering. Welcome to the podcast, Professor. We're delighted to have you with us. So, Professor, in your Galam Galam interview, you talked about your background, graduating from the Indian Institute of Technology and securing the first position across all disciplines. That's a huge achievement. And it clearly takes not just the talent, but curiosity and persistence. So I would like to ask, can you tell us how that journey began?
As you know, I was graduated from this IIT in India. And so getting into IIT is again quite difficult. And then going through all those courses, interaction with the professors and young minds, your peers, it was altogether a very nice experience put together. So I have been always very curious, and I have this habit of asking many questions. So when I don't get answers to these questions, I try to answer by myself. And it wasn't too difficult to get this kind of first rank. Yeah, but it really helped me a lot later.
And was that drive for knowledge something that started early, or maybe, school, or was it shaped by your parents or mentors?
True. So as I said, I was so difficult kid because I used to ask questions to everyone.
Yeah.
It's like, what's after this galaxy, and what's after that? Where does it end, and what's after where it ends? Everything, and why are we born?
Yeah.
And what do we do, and where do we go? What's life after death, and all that? So I had many questions.
That's right.
And then gradually I started answering my own on my own. Like, why would a reflected ray would take the same angle about the normal as incident? There were many questions. I was very keen to learn physics and math, and that's probably took me into it. And I was a good student for physics and math. Probably, yeah.
And what was like this culture around math and physics in India, for example? How teachers encouraged it?
I could attach with these subjects more because they come from our ancient philosophy. Because in all those ancient books, there's a mention of math and physics quite a lot. So the algebra in math, trigonometry in mathematics, for instance, and the mechanics in physics, for instance, and all these were very close to my, early bringing up. And so, for instance, if you talk about math, there's something called Vedic mathematics that comes from very ancient scriptures in India. So it was something not very alien to me, and so I started liking these subjects.
Thank you. And what the earliest memory of you building or fixing something, maybe starting this engineering journey?
Oh, it's not building and fixing, but actually I pretended to have created a radio in front of my parents to impress them, connecting few wires and on a board, and I was pretending as if there's a radio and I was singing behind the curtain. But that's a funny case. I had actually created a robotic system when I was in school, and that drove me further. It was like, I'm an old person, like I'm talking about something 40 years back in time.
Yeah, but actually that's interesting, I think, the journey and everything, your childhood. And in what ways did your parents shape your curiosity, discipline, maybe in your family? How was it like?
Well, my father and mother, both of them, they are very good at reading books. So we have a small library in our home. So since my childhood, I've seen books around me. We have more than 1,000 books at home.
Oh, that's impressive.
Yeah, I've read a lot.
Yeah. A non-academic lesson from home you still use today?
My father used to tell us stories. And he used to tell these stories in such a nice way so that everybody would be enchanted and, would listen very carefully. So that probably made me a good teacher, probably, because I can explain things that would be comprehensible to many different kinds of people, because everybody understands differently. And so you have to explain things in such a way so that everyone can understand. So yeah.
It's like explaining to a child everything, yeah.
Uh-huh.
Next question is about your further PhD in New Zealand.
yeah.
I mean, you later won a doctoral scholarship at the University of Auckland in New Zealand and even stayed there as postdoctoral fellow. That's a big leap, both culturally and academically. So I would like to ask, what was that experience like, moving to a completely different environment and adapting to a new academic life?
Yeah, that's true actually. Acquiring this scholarship was very difficult because it was just one scholarship in the entire School of Engineering across different majors, just one scholarship for foreign student, and I was able to get that. Completely changed academic environment because in India, there are two different kinds of, or rather, I would say that the academic environment changes from west to east quite, hierarchically. Like,
Yeah.
while it's quite open in the west, towards east it becomes more hierarchical and
Yeah.
yeah. So I was really happy to see in New Zealand that I was able to kind of have a debate or argue with my supervisor, PhD supervisor, or I could talk to any professor in a very friendly manner, as same as I was talking to my peers. We used to have very healthy discussions and and deliberations and sometimes disputations and whatever we call it. So it was quite a vibrant culture that I could find myself in an open environment and I was able to express more explicitly.
And the people there, were they accommodating, I mean, for the foreign students?
That was surprising to me because, in those days in New Zealand, very few, it was not heavily populated like it is now.
Yeah.
So on the roadside, when you're walking, people coming across would always say hello to you before they're passing to you. It was kind of a culture, and it was so nice to see that people are so welcoming and so polite, and so welcoming actually. So it was very easy for us to get accommodated, and I would say I enjoyed a perfect work-life balance there.
The balance, yeah, that's, I think, great, amazing point. And moving on to the next question, what were the most important lessons you learned from those different academic cultural environments?
I would say it was kind of a relearning of the same ancient concept of education, which emphasized more on exploration than dissemination of knowledge. Mm-hmm. It's like in our ancient times, in both in Indian and Chinese systems, the system of learning was exploration by asking questions, and both teacher and student were considered to be at the same level. So they're both exploring something.
Together building you.
Yes. So it is said that we'll live together, we'll study together, and we'll know together. So that's kind of a thing that I could see once again in New Zealand. They had a system where no one would say that this is the end of everything, everything, every discussion would actually eventually emerge into some new concepts, new ideas. And it was such a encouraging, experience for me that we could actually argue with the big professors and put forth our point of view, and they would listen to us.
Yeah, that's interesting, and I think supportive for the students. I mean, to explore and not to be afraid of like doing the research.
Exactly. That's what I normally do in my classes. I encourage students to ask questions, because that's the only way to gain knowledge and to acquire knowledge. There's always a knowledge, but to acquire it and to make your own, you should ask questions and then make it your own learning.
And what do you miss most from India or New Zealand?
You're talking in terms of Kazakhstan, right? So when I'm here,
I mean, in terms of Kazakhstan. Maybe when you're in India, maybe you miss something, the environment or students here in Kazakhstan. You could tell in each maybe country.
So when I go to India, what I miss from here?
Yeah, from here and here from New Zealand, for example. Some moments maybe. Yeah.
Yeah, it was quite a big contrast coming from New Zealand to Kazakhstan because it's a very green country. They have many big domains and parks all over. And here we only have them for half of the year. But the people here are quite warm, quite welcoming, and students have found them very intelligent, and especially students coming to Nazarbayev University, of course. They are brilliant. They can be shaped into good educators or good entrepreneurs or whatever they want. So I would say that in New Zealand, students coming to engineering were only those who were interested in engineering, right? And very few of them. But here we find that almost all the students in your class, they would be very intelligent and curious. And the young generation in Kazakhstan, I have high hopes from them. I'm quite optimistic. And they're really changing the country a lot. So I'm really inspired when I go to India, for instance, and talk to, and sometimes I'll go and give keynote addresses or visit other universities in India, and then I'll start talking about students in Kazakhstan and praising them there. Yeah, same with in New Zealand again. My own son is studying there now, and you know what he says, that Astana is better than Auckland.
Really?
And that's a big compliment for Astana.
Yeah, I think
because my son lived here for 10 years, and he was born in New Zealand, but he lived here for 10 years, and now he says that it was more safe and vibrant in Auckland and in Astana than in Auckland. So I'm happy to hear that.
Yeah, that's really interesting to hear that Astana is better.
Yeah.
And that's interesting. I mean, story, the background, everything. Now, I'd love to shift to the heart of your work, engineering and innovation. I mean, over the years, you've led projects in robotics, AI, and even space technology. And I would like to ask, across all your projects, from robots for rehabilitation to nanosatellites, what's the common curiosity that ties them together?
Well, from the engineering point of view, these are all cyber physical systems which have sensors, actuators, mechanisms, and a controller, right? A brain. So, to me, these are all bound together to control designs and making something move intelligently. So, the journey started here in 2017 when I started working on a project on my own. And for a long time, I actually wanted to create these robotic systems to help people with disabilities, basically. Yeah. So we started one project in 2017, and then finally created it and presented before a committee from UN here in Astana. There was a exhibition. It's called Digital Bridge. Mm-hmm. It's not exactly this digital bridge. It was like back in time. I'm talking about in 2018. We participated in that exhibition and presented our first robotic system, and people were impressed. So we were invited to United Nations. I went there together with the Vice Minister of Health, and we presented our robotic system there. It was everybody praised it, and they loved it because this was a special robotic system that you could actually actuate or change modes using your thought process. So we were using EEG sensors that time to make robot change its modes. So that was interesting. But the first robotic system that I created in New Zealand was a big failure, of course. Because we created a robotic system and then we gave it to the doctors in School of Medicine to use it with their patients to see how they improve. But after a couple of months, these doctors, we once again had a meeting and they said that your robotic system is a waste. It's like it doesn't work because our disabled patients, they become dependent on your robotic system because your robots is moving their legs and arms.
And there's no improvement.
So they're just sitting and the robot is moving them. So it doesn't work this way. And we don't need this. And then we started to work on this robotic system. That we understood that the robot is not there to help patient always. It should help in the beginning and then gradually retract and let the patient work on their own. And towards the end, the robot should actually be opposing the motion so that the person can actually train on resistive training kind of mode to strengthen the muscles further. So we created another kind of controller system and we named it as like assist as needed. It was the same time when I was like studying some educational philosophies from like Montessori and these kind of things. And so in Montessori education, they talk about scaffolding, child only intervene when the child needs you. And I could create a controller for my robotic system that assists only when the patient needs it. Otherwise, the patient should be encouraged more into this treatment. So the first implementation here, which we did, was like the patient has to think that they need help from robot, and the robot would help. Otherwise, it will not. So that was the innovation, I think, which was present in the United Nations and was selected first as top 20 innovations.
Yeah, actually, that's fascinating for me, the robots, and especially in medicine. And what was this? What were the steps maybe in creating such robots? I think, and maybe you can talk about the students or those who were involved in it.
Right. So since 2017 to 2021, it's like for 4 years, I was working with different students at different times because students would graduate and go, and then new students would come and join me. And then, so we started with a project where we created exoskeleton legs to help a disabled person to walk on the treadmill. I mean, a person cannot walk by themselves. We created a body weight support system for the person to be hanged on a treadmill to make them stand there on a treadmill, and then the legs will be attached to make them walk on it. So we failed many a times. I still remember the fourth prototype was the one which could successfully move the legs of a person and to help them walk on the treadmill. So before that, we had like 3 failed designs. And the fourth one was finally presented before a team from World Bank in 2021. I still remember that. They praised it, they appreciated it, and they further promised to help us. And then since then, we continued. So there have been so many students working with me since the very beginning. Some of them, they have become entrepreneurs. Some of them have even become professors in other universities. Some of them still continue with me. So, yeah.
I think that, that's interesting. What was maybe some funny or interesting moments with those people, I mean, students you worked with? Maybe there was you were talked about the failures or something.
See, every student is different, right? As I said, I have my students working as like associate professor in universities in UK, Muhammad bin Zayed University of Artificial Intelligence in Australia. At Nazarbayev University, I have my students working as assistant professors. But there was one student, I still remember, I thought he would become a good professor in some university, but eventually become an entrepreneur. He's also teaching in a university, of course, but at the same time, he's got his own startup companies. He's rather doing better in his career as entrepreneur and doing business. So that's something different, amazing, and yeah.
Another question about those research. I would like to ask about AI, because AI is such a vast and fast-moving field, and you've been deeply involved from conferences to panel discussions, for example, the digital bridge, and on AI and robotics. I'm curious, how has your definition of intelligent robotics evolved since you first started working in this area?
That's true, because I've been teaching artificial intelligence since 2003.
Yeah.
So it's been more than 20 years now. And I was amazed to see how human evolution can be mathematically used to evolve solutions, how neural network can be modeled to drawing inspiration from human brain, how a fuzzy logic can be mathematically used to work with qualitative variables like very far, very close, and So I was always interested in using AI and implementing it. So when it comes to, for instance, to my robotics, so I've been working with robots since very beginning, like since 1996, I remember. So the initial concept of robots or automation for me was like a good controller based on sensors, and a predictive automation kind of thing. So the controller, the earlier controller that I used to design has been turned into a cognition nowadays. And then, so when you're talking about a controller, now it has become an intelligent controller. And so when there's an intelligent controller, it can do many things which we were not able to do it before. So we can personalize our robotic systems now based on these intelligence that we could include in our robotic controllers. So, when we work with the patient, so during the initial trials, the controller would collect lots of data from patient. It's spying. Collecting lots of data, the controller would understand about this patient. And then it would start from the correct mode of operations. It customizes the talks required. Previously, we were only aiming at achieving certain angles, for instance, joint angles or something, or achieving certain forces coming at torque coming at the joints. But now we can actually think of planning the entire treatment, have stated outcomes from this treatment for a patient, and bring those targeted goals into the controller, so the controller understands how they have to change the modes of its operations and interaction with the patient. So AI really helps us in designing customized robotic systems.
Yeah, and what role do you think that these universities like NU playing in ensuring that AI innovation serves society and not just industry interests? Because there's always a debate whether we should trust AI or not.
That's okay. I mean, for instance, medical practitioners, they were not in favor of using AI before because they work with human beings, right? And so they would not like to use an AI algorithm or a platform that works like a black box, which they do not know what's inside. So over the time, we have worked on it, and we trying to come up with more explainable AI, or for instance, this year, starting from February, we start working on something called chain of thoughts. So when the AI algorithm is inferring something, it would also give reasons why it is inferring something. So those chain of thoughts would actually convince the user that the conclusion drawn by this AI platform is convincing, and they would accept it. But yeah, at Nazarbayev University, we've been doing so many things, of course, apart from just educating students here. We have ESI, Institute of Smart Systems and Artificial Intelligence. They are working with the language models. And then we also have developed a Center of Excellence in Medical Research and Robotics, where we have two verticals. One is robotics and one is artificial intelligence. So in robotics, we develop robots for the treatment of disabilities, and we're also working on a very interesting robot, surgical robot to fix fractured bones. And under this second vertical of artificial intelligence, we are trying to create artificial radiologists and pathologists, but not to replace the human radiologists and pathologists, but to help them with catering or with analyzing more and more reports in a shorter time. So my idea is to create such kind of artificial intelligence hub, which can help these medical practitioners in making quick decisions, for instance. So we are doing all of this to eventually impact the society and the industry at the same time, because it is an industry through which we can actually serve to the society. The thing is, we do some innovations. We try to bring all these stakeholders together, like government, medtech companies, researchers, and then the research centers where we find our patients. So we all work together. We ask funding from the government. We bring in medtech companies to work together with us. And then eventually when we come up with some innovation or some product, for instance, how do we send this product to the real beneficiary in those research centers or hospitals is through these medtech companies. So, for instance, recently we have almost finished kind of all the regularization and certification required for a gait robot, like a robotic system that can help people walk on the treadmill. So it's a robotic system, but then since it has to be installed in a hospital, it has to go through certain regularization and certification process, which is very strict. We require some sort of ISO certification. So we finished all the tests for now in an ISO certified lab in Moscow. And yeah, very soon you would see, starting from next year, 2026 next year, in the first quarter, we'll come up with this commercialization of gait robotic system in one of the hospitals here. But then industry has to support again. So, we have to work with taking all these stakeholders together. If I just become a researcher and finish my research in my research lab, so the research is born and died in the lab itself. It cannot translate into clinics. So to send it to the clinics, I need help from all these stakeholders. So we work with all of them actually. Yeah.
I can see that's more complicated process rather than just research. I can see the work between collaboration, because I don't think it's easy. You need people from medicine, government, and everything involved in it. And what do you think the most, maybe some challenges that is impeding?
Yeah. So as I said, my fourth prototype was kind of functioning. And then we started to, and of course there's so much goes even before that, for human trials, you have to obtain ethics approval, which is very difficult to obtain. You have to be very watchful for everything. And then you work with the healthy subjects first, and then you start to work with the patients. It's again another kind of ethics approval you would require. After the ethics approval, then at the same time while you're working with your robotic system, you're working with these bureaucracies, which is again required, I would say. The place where I create my robotic system has to be approved by another authority. So we have to obtain a license to work on such kind of medical device. And then we had to go to different hospitals and centers to do clinical trials of phase 1, 2, and 3. We even went to Karaganda, taking all our robotic system. It really is difficult to take all these big robotic systems to different cities. And then eventually when we were required to have this kind of certificate from an ISO certified lab, we were disappointed that there wasn't any lab in Kazakhstan, so we had to actually go to Moscow. And then we struggled a lot there for 10 months. It was a long process of protocol that they follow. It's like they also follow this GOST standard, which is close to ISO, and it's a 300-page long protocol. We finished everything, took time, but then it is the persistent and perseverance from our side that has actually sailed us through all. Working with the research centers or rehabilitation centers is again not easy because you have to have a MOU signed with them, you have to convince them, and then work together with them. So we have been able to work with many centers. For instance, we work with rehabilitation center. There's a center for traumatology and orthopedics, and then we also work with this oncology center here.
Yeah.
And yeah.
That's, I think, just interesting. You were able to, show the processes behind those projects, and that's fascinating that it's much more complicated than we thought about the research. Thank you very much, I think. And here I would like to ask about one of your key projects. It focuses on developing robots for rehabilitation, maybe, and especially your course about developing those robots.
Right.
And can you talk about the students and how this course is led?
Yes, I always wanted our students to know what they can do from what they have learned so far. So in the final year of engineering, I thought of giving them a course where they can actually work towards a project and create a product. So, so the idea was that for engineering students, we'll give them a product at the start of the course, and then they would learn whatever they require to learn to make this product. So they go through the entire cycle of developing a product from scratch, from idea, and then eventually completing it into a functional product, and at the same time, as I said, learn whatever they need to learn in making this product to a functional product. So it was good for engineering, and then I figured out that engineering students, they would require some other domain knowledge in medicine which they don't have. So I started the same course with medicine students also, so that these students can help engineering students with their domain knowledge. At the same time, engineering students can help medicine students in actually implementing what they want to create. So yeah, this course is a unique course, and it's interesting to see that recently, there was a competition, an international competition across six continents, including Australia, New Zealand, China, Asia, and we submitted this course from Nazarbayev University, and we won this award. Actually, it's called GMA Award. It's quite prestigious, and so it seems that the international community and academics, they also like this course. This idea of a course where students from engineering and medicine, they collaborate in creating a product that can help disabled children or disabled people in regaining their movements and strength. So
that's, I think, just really interesting idea of combining medicine and engineering. I wanted to ask about it too. And you've mentioned that you teach in both School of Engineering and also School of Medicine, which is pretty a rare combination. And what's that experience like? Bridging two very different academic worlds.
Yeah, it may be a rare experience, of course, but I always wanted to interact with School of Medicine students. I was in touch with them before, and then when I got a chance to work with the School of Medicine in teaching a course, I was always, excited. So it really helps to teach School of Medicine students whatever I've learned so far in stroke and rehabilitation and cerebral palsy. Because this is the area where I've been working for past more than 20 years. And then students in School of Medicine, for instance, they're excited to learn about modeling techniques and working with different kinds of software. So I teach them different softwares to learn human movements and biomechanics, and they're always excited. We also try to teach these students a little bit of artificial intelligence, which they normally don't have access to. And when they see that it's so easy to use these AI algorithms, they are happy. At the same time, School of Engineering students, they're always excited about working in biomedical things or medicine-related projects. So it's like both engineering and medicine students, they're enchanted towards each other's area. And I found this to be interesting to bridge them together. And in fact, we have different schools at Nazarbayev University, but there wasn't any platform where professors and researchers from different schools can come together and do a collaborative research or transdisciplinary research kind of. And so moving ahead, we created a Center of Excellence in Medical Robotics and Research, which has a lot of participation from professors across different schools. Like we have one professor working from Graduate School of Education, SSH, and then School of Medicine, Engineering. So it gives quite a feeling of satisfaction that we have created something which allows different researchers to come together and interact and do some transdisciplinary research.
I really think that everything goes well because I can see that the research is sometimes about bridging different areas like that, and I see a lot of things. And I want to ask, looking ahead, how do you see this interdisciplinary direction developing here in Kazakhstan? Do you think we're moving toward a future where medicine and engineering merge more deeply?
That's sure to happen, of course.
Yeah.
So this interdisciplinary culture is increasing gradually. I can see more and more interactions, and I can see more and more SSH and engineering school professors taking interest into School of Medicine projects. So, for instance, recently I started to work with children who have cerebral palsy, and so we work with these children in enhancing or improving their mobility. At the same time, I was also interested to improve on their communication and social skills, for instance. And then the idea came to me that how I can teach these children so that they can attend a regular school. And so I looked for a professor who can create such kind of an educational intervention that over the time can train these children to be admitted with other normal children in the regular school. So that's how we invited a person from education. And then we work with psychiatrists, we work with neurologists, we work with therapists, and then we also work with all kinds of engineering professors, like in electrical, mechanical, and computers, for instance. So, yeah, it's quite, as I said, interdisciplinary. And so over the time, I would see that, or you would see that, the engineering and medicine would work together more closely because, and that's the basic philosophy of creating a university like Nazarbayev University, where you have all the faculties at the same place. And we have School of Medicine and Engineering and, business and education. So there was a time when people were thinking more of like specialized university, like technical universities or medicine university. But a multi-faculty university like Nazarbayev University is an ideal platform, I would say, for some real innovation. Yeah.
And if I'm not wrong, you're working at Nazarbayev University since 2014, and I would like to ask, what changed in this? I mean, maybe student environment or Nazarbayev University itself.
Yeah, over the time, everyone has become more busy. We used to have a lot of free time before, but nowadays everybody has become more sincere and more involved into research because previously research was like, it was kind of an aspiration. Okay, if you're doing research, it's good, But if you're not doing research, you're good, just teaching your students, it's okay. But over the time, because the university is gaining reputation, and so we have to carry a bit of responsibility on our shoulders too, to take this research further. And so I can see that most of the faculty, they've started taking research projects now. Earlier, there were very few. And we have started to get more and more good students, of course, as usual. Faculty, of course, previously we used to have professors from many countries. Like there was time, I still remember, we had 660 professors coming from 66 countries. So that was quite interesting thing. But yeah, gradually we keep getting international faculty, of course. But at the same time, I'm so happy to see that more and more Kazakhstan faculty members from Kazakhstan, they are coming back to Kazakhstan, which is quite amazing. And one of my student, I can say, I co-supervised him for PhD, and he was studying in Australia. He was thinking of settling down in Australia, but then later, when he saw me developing a center here, for instance, and a platform like Nazarbayev University exists in Kazakhstan, so there is something brought him back. So we are also actually, bringing in back the talent that was drained out before is coming back to Kazakhstan and to Nazarbayev University now, which is a good sign. Yeah.
Yeah, I think it's good that others are also interested in this, because I can see that too, that it's being recognized. And about that, what emerging research direction excites you the most? Are there areas you believe students should pay attention to?
Yeah, of course, research areas are important, but for students, it's more important to learn and acquire more and more research tools. Artificial intelligence, no doubt, is going to be the mostly used tool, and they should definitely learn. But that doesn't mean that they should not learn statistics or mathematics, for instance. Everything counts in research. Those who are interested, they should have good mathematics background. At the same time, they should be inquisitive. We normally don't look for smartest students. I just want to see in my student whom I'm hiring as a research assistant that they are for everything. If I ask them, can you do something, they should say, we will try. If there's a student who would say that, sorry, I cannot do this, that shows that they don't have this kind of inquisitiveness or ambitions. So yeah, students, they should have these basic research tools. At the same time, they should be ambitious and explorer.
That's great points. For those who are wants to become, researcher, maybe a research assistant, because they all begin with this research assistant,
yes,
in order to find the area. And if you were to give maybe 3 key pieces of advice to undergraduate students at the NU who want to pursue, research, what would they be?
Yeah, to me, research is something that impacts society directly. Of course, there are professors who like to do theoretical research, who like to work with developing new concepts, new foundations, of course. But to me, research that translates into something real impact on society has more meanings. So the first thing is for students to do research. They should be ambitious, they should be curious, and they should find ways how to help society eventually.
And can you talk about your, philosophies maybe you follow? Because you mentioned that you seek that it helps to society. What else you see in while engaging maybe in new project or
Right.
Research?
Yeah, I like projects that have challenges which you can solve through mathematics and physics, of course. Because to me, I think that everything a human can think is possible. So, in other words, I would say that we cannot think impossible. So, of course, everything is possible, but then doing meaningful things would always attract me. So, a research that impacts society in a positive way, like helping disabled children, for instance, or helping doctors in diagnosing or coming up with their findings very quickly, making a nice system for that helps people in general. So such kind of research would always attract me. Yeah.
Thank you. And we're coming to the end. And to wrap up, I would like to ask some quick questions. Maybe you can answer them. If not academia, what parallel universe career would you choose?
Well, academic and teaching is very close to my heart since I was very child. But of course, if not teaching, I would be working in industry, and not as a worker, but as an entrepreneur. And my suggestion to all the students in Kazakhstan. See, in my class, I always tell my students, Kazakhstan has less number of industries. We need more industries here. We don't need many workers. We need many entrepreneurs.
Entrepreneurship.
So,
Yeah, thank you. And a small daily habit that has an outsized impact on your happiness.
Oh, really? Well, it's my own habit, and I'm not insisting everyone to do it, but I eat less and work more. So I get up early in the morning and try to be active the entire day. So
That keeps you focused there.
Yeah, so
Yeah.
eat less and work more is my motto.
I mean, that is working for you. So
And
I think that's good.
it really works
Yeah.
for me, and it would work for everyone.
Yeah,
Yeah.
I think so too. It gives you this focus. And about the environment, mountains or steppe?
Well, sorry, I like mountains. I'm a mountain boy because I was born in India in a place where we had lots of mountains. So I like Almaty. But Astana is also good.
And day or night research?
I'm a night researcher, of course.
And what is about night? You have more focus or?
Yes, people are not messaging me and not
Oh.
asking questions, and I can be with my own research myself.
Yeah. And favorite invention ever?
Ah,
Or maybe
well,
several.
Well, I had actually invented a new optimization algorithm that could simultaneously optimize any number of objectives, any number of variables. It was going to be a big innovation. But then somehow my focus was changed to devices, and I started making robotic systems. So the first achievement which I consider was this invention of a multi-objective or multi-criteria optimization algorithm that I created. The other invention I would be I'm more happy with is like this a gait robotic system that is helping people with lower limb disabilities, and they would continue helping them later as well. So we work with stroke patients, and we are working with children who have cerebral palsy. And when they improve on their walking, they are happy, their parents are happy, and it gives a sense of satisfaction. Yeah.
Thank you. And one thing you can't teach? Or you have this stake that everything can be taught?
Yeah, when I started teaching in School of Medicine, people were like commenting on me like, what is this? How can an engineering graduate teach school children and in course on medicine? But then I had also taught a course in School of Business. So I don't think there's something that I cannot teach. If there's something that I cannot teach, it's just to myself.
Always, I mean, forever student.
Yes.
Paper or presentation?
I would prefer presentations.
Harder to deal with reviewers or students?
Well, reviewers are not sitting in front of me, so I can deal with them easily. It's the students who are difficult to handle with when they are sitting in front of you asking questions. And I really like it, love it.
And if you had one superpower, what would it be?
Well, I'll try to make everyone happy.
Oh, that's really nice to hear. And a word that describes your PhD journey.
Lots of stress, pressure, but there was always an ambition that always drove me. And the approach, there are two kinds of approaches. One is called perseverance, and the other one is called tenaciousness. So more kind of tenaciousness sailed me through. Yeah.
Thank you, Professor. And I think this whole journey that you shared is remarkable and interesting. And I hope our viewers will find some insights or new ideas for themselves. So thank you, everyone. Thank you for watching us. See you in the next episode.
Yeah, thank you. Thank you for taking me through my journey again. Thank you.